what is energy? Okay, so we got to from the layman point of view, we have to find out what's energy. So we have a lot of people keep talking about this gentleman is, even though he's 86 years old, 88 years old, he's very energetic, that way, energetic, right? So we usually describing somebody is energetic. Energetic means full of energy. Full of energy. So that they already informed us. So why you think this guy is full of energy? So we observe this gentleman. He's my associate. His name is Werner. Werner was my boss at Pasadena State College. The guy is him to do. He finished real fast and he came to me. So what does that mean? He's a fast worker. W-O-R-K-E-R. Very efficient worker. So we call he's very energetic. So by doing all this, energy is related with work. So what's that mean? Energy is capabilities of doing work. See, the language is very, very simple. Energy is capability for doing work. It's the gentleman is energetic. That means he's full of capability of doing work. Now we're referring to as the fact. What is work? Okay, what is work? Okay, so Isaac Newton studied this. What is the word? Okay, it says work is related with agriculture, right? So nowadays, the people say, here is a pile of coin. You want to lift up and move and put it here. And lift up and put it here. That is called work in agriculture sense. Now we remember, during in 1666, Isaac Newton is going college time. Around that time, what kind of society like that? Agriculture society. Doesn't even go to steam engine yet. It's agriculture society. Agriculture society meaning that they plant something, they get something, and then move some hay to one place to another places. So when you move a hay, what you need forces. Okay, you need forces. So they define the word is the product of force and distance. So all the basic information you already have. So immediately that is what is in W. W is equal F times D. Okay, so the forces, if you're looking at it, now we have to draw a diagram, right? Nicely, if you do the force more effectively, you do this. This is called physics conceptual drawing. You have a load, in which case this is an M, G, and then right in here, that is F. You move, and then up to here, move to the distance here, in which cases that is called distance D. Now the force can be variation, in which cases can be something like this. Move with an angle. The distance and the angle different. So reach to here, and then so that's the reason why the force is a vector, and R is a vector. So that's why you dot. So what is F dot R stand for? Means F times R cosine theta. Theta is the angle between the force and the distance in move. It can have a different, for suppose if x, then you can say the work along the x direction is equal to F times x times cosine theta. Okay, so this is the generally you're talking about. Now we can go the other way, means how about the force vertically? So in these cases, the work is done by the force along the y direction, in which cases F of the work is equal to F times y. This is along y direction. Y direction. So now we like to work on this a little bit more. There's some pile of cement. The cement have some weight, in which cases is called W. And then the force push it up, in which cases we like to say Fy. So the force push it up. So in their cases, move like this, right? So we ask, what is the acceleration? In which cases is a vertical acceleration. Suppose this is pointing upward. So in these cases, when we do this, we do a wet, what they call force diagram. The net force applied here, you have a Fy minus summation F net. The net force equal to Fy minus W equal to Ma, in which case this is a mass equal to M. So something like that. So the association with this example, A is equal to Fy minus W divided by M. This is one of the physics study 1A, the first video. Just ask this simple question. Do you understand that? Do you know how many people don't know how to solve this problem? 50%. Because I played a trick on them, right? I said the mass is M. I just say the mass is M. The people didn't figure out that there's gravitation force push down. Okay, so there's gravitation force goes down, there's W. So that's why we like to emphasize one thing. When you study the problem, make sure that you read the English very clearly. Okay. In this class, we will not give you the Nobel Prize winner question, right? We just give you average question. Okay. Yes.
For W, could that be mg?
Yes. Okay. We do. Sometimes the teacher trick you. He says there's some force, a force Fy push a object with a mass m upward. What is the association? We didn't tell you about the weight about the object. We just say, hey, this object is a mass m, so I use it so much force equal to ma. That is wrong, right? Okay. So read your problem carefully. That's the reason why we need you to draw a diagram. Okay, this is the key. In the engineering work, it's the same. In engineering work and scientist work, they are the same. Then you have to stare at the problem stare at the design, stare at the circuit for at least 30 minutes or 20 minutes. It doesn't give you too much chance to look at the problem. Because the test system, they want the people compete so that they can pick few of the students to get to the college. Now the situation is changed. We are more emphasis on the understanding. Speed, well, you have calculator to taking care of all this, the necessity of speed. If you draw the diagram properly, and then carefully, and the explanation very carefully, the problem is already basically is the substitution and getting the verbal number, and you keep pushing the button and you getting the answer. Okay, so that is all the exams like this. Okay. So now we are talking about something is important underneath it. The force is constant. The force is constant. A lot of times the force is not constant. For example, the spring. We have a spring here, but later on we will take a spring here. The spring is not a constant. Something like this. So there's a hanging like this. Or a spring is like this. You push. So the force of pushing back. The force is depend on the extension of the object. See, if the force is in this situation is x spring. In that case, for example.